Video is meant to show you how to use MATLAB symbolic functionality in order to calculate the derivative of a function. So let me be specific. So what I'd like to do is write a MATLAB function that takes as input a MATLAB function that corresponds to an equation of a single variable and then outputs another MATLAB function that would output the derivative of the function that was sent to it at the value of x that is specified by the user. So let me just use an example. If I said y is, I'm going to define an anonymous function, and so y is sine of x. So this is a MATLAB function. So if I say y of 0.1, that should be the same as sine of 0.1. Remember, MATLAB uses radians. Now the derivative of sine is cosine. So let me just define a function y prime. So now y prime would give me the cosine of x at a specific value of x. So if I said y prime of 0.1, I should get the cosine of 0.1, which ought to be fairly close to 1. Now, in order to define these functions the way I did, I had to do the derivative myself analytically. And I don't want to do that. I want to use MATLAB's symbolic functionality and let MATLAB do the derivative. I also want to make it clear that this is not a numerical derivative, it's an analytical derivative. And normally MATLAB is designed for numerical methods. There are numerical methods to calculate derivatives. For example, you could examine how a function's value varies with a small change in x. I'm going to talk about that another time. Right now I want to focus on using analytical math. So in order to do this, you have to recognize that the MATLAB function and MATLAB variables, as we've looked at them, are actually very different from symbolic variables. Like, so let's say, for example, I said x. MATLAB is going to give me an error. Now, if we were doing symbolic math, there's nothing wrong with writing x. Even if we don't know the value of x, x is a variable. That's fine. So let's actually use the symbolic toolbox. So I'm going to just clear the memory, clear the screen, and I'm going to say sims x. Now x is now a symbolic variable, so if I say x, MATLAB doesn't give me an error. X is x. Right? So if I now say sine of x, that means something in the sense that x is a variable and the sine of that variable is also a variable. Right? But now I have to use different different kinds of commands to work with this. So for example, if I say y is equal to sine of x, and I say y of 1, which I did earlier when I defined y as an anonymous function of x, notice that it doesn't actually know what that means. It's because y is actually not a MATLAB function. Right? The word function can have two meanings in math. That meaning is different from what it means in MATLAB's world, or in computer science perhaps. So I could do the same operation using the substitute command. So if I say subs y x1, so what this means is to calculate or to take x from a symbolic expression and just plug in 1. Now, that sort of worked. It gave me sine of 1, but it didn't actually calculate it, right? It didn't actually do the math, right? But I could force it to with the double command. Double actually means double precision floating point. And it now does the calculation. So let's double check that sine of 1 is in fact equal to that. Sure. Now, there are certain advantages to symbolic math, right? So this is why I'm telling you about it. So for example, there is a diff command that says calculate the analytical derivative, or do the symbolic math and get me the analytical derivative to the expression y. So now MATLAB has actually given me the analytical derivative cosine x, whereas before I just knew that that was the answer. And so this functionality can be handy because when you're working on problems that require the derivative of function, you can use this functionality to convert or to calculate the derivative. But one thing you do have to realize is that if you expect to send the function a MATLAB function and get back a MATLAB function, you can't just output an analytical derivative. And so you have to actually be able to convert from symbolic expressions to actual MATLAB functions. So the simplest way to do that is to use the function MATLAB function. So if I say, I'm going to say y2 is MATLAB function of y. What it's done here is recall that y is sine of x, but this is a symbolic expression. But now y2 takes that symbolic expression, recognizes that there's only one variable, and it defines a MATLAB function, in this case an anonymous function, that corresponds to that symbolic expression. So now I can actually plug in 1, into y2. Actually, this illustrates the difference between y and y2. So MATLAB sees y as just being an expression, so y of 1 does not have a meaning. You'd have to use subs to actually plug in for x. Whereas here y2 is a MATLAB function, it has meaning. Now I could manually define a MATLAB function. That may be more intuitive, but it has its own drawbacks. So I can say at x double subs, let me match my parentheses, y comma x comma, actually sorry, let's not use x here, let's say x1. Okay, so what I've done here is I've taken the analytical expression x and I have defined a MATLAB function, an anonymous function, that will take any input and do the plugging in to actually output a number. So if I say y3 of 1, I have effectively done the same thing that the MATLAB function command does, although there are some subtleties there. We'll discuss that shortly afterwards. Now, I think we have the tools necessary to actually write the function that we're trying to write. So let's create a new function. I'm going to call this function derivative 1D. And I'm going to take as input any MATLAB function x. So I want to make this clear. So input f is a MATLAB function. It is not a symbolic expression. As we've discussed, there's a difference. And I'm going to output f prime and f prime is, so f prime will be a MATLAB function, corresponding to the analytical derivative of f, or of the expression for f. So what I need to do is start by converting f from a MATLAB function into an analytical expression. So I can do that by just saying simsx, defining x as a symbol, and then saying f prime symbolic is equal to f of x. Okay, so actually, hold on. Let me just call this f symbolic. I was debating between doing multiple steps. So f symbolic is now f of x. I'm plugging in the variable x. So now I can say f prime symbolic is just diff f of x. I think diff would be smart enough to not require this second input x, but let's just put it there anyway. And now f prime can be converted back into a MATLAB function. So f prime symbolic Okay, so that ought to do the trick. Let's test it. Okay, so now let's say f, our function derivative 1D. I'm going to say at x sine of x. Whoops. I don't think I was supposed to capitalize diff. And there's that problem with my N button. Sorry. During the pandemic, I haven't had time to buy a new computer. And looks like I misspelled symbolic f prime sy m. I don't have the excuse of my I have with n's because my m key works fine. Okay, so now you can see that I sent it a MATLAB function sine of x, and it gave me back a MATLAB function cosine of x. Now this video is actually meant to stand on its own, just to talk in general about symbolic math and derivatives, but it is part of a playlist on solving the Colebrook problem. In other words, an example of the an example of a root finding problem. And so let's actually you can look at other videos to see how this is defined, but we wanted to use Newton's method to solve this function to solve, and it's kind of a complicated expression. It's the Colebrook equation with all the terms moved to one side. So let's actually just take a look at what function derivative 1D is going to do with to solve. So actually I'll just, rather than modify the script, I'm just going to run it. And it should define to solve. I'm going to say to solve of x. Oops. It wants to plot something. Oh, whoops. X is not defined. So x is just a it's an anonymous function that calls the Colebrook equation. But let's actually see what function derivative 1D does with it. 1D Okay, so we actually do get a derivative. So it's a rather complicated expression, but we did get what we wanted. So MATLAB did the work for us to calculate the derivative. So before I end this video, I want to make a couple of comments. And so one is a critique of the MATLAB function itself. So the matlabFunction function. So there is no issue with our current use of it, and that is because there is no ambiguity for a function that is dependent only on one derivative. One variable. Now, what can cause confusion is that if you use matlabFunction on a symbolic expression that involves more than one variable, then matlabFunction has to guess the order of those variables that you actually want in the arguments. Let's imagine that I have a symbolic expression that depends on x1 and x2. And you use matlabFunction. So actually, let me just define it that way. I'm going to say sims x1, x2. And I'm going to say f is, let's say, x2 cubed plus x1 squared. Let's see what matlabFunction does. It may or may not do what I'm expecting it to do. Okay, so it did the right thing. So it defined an anonymous function that depends on x1 and x2. Now, what can happen is it may guess that the order of the arguments would be x2, x1. So it could declare a function that is at x2, x1. And that can cause you confusion because as a human, it would be obvious to you that the logical thing to do, or it's actually not logical, is to order the variables x1, x2. But what can happen is that if matlabFunction has to guess the order that you want to define your variables in the arguments for the function, it may guess something that is not intuitive to you. And for that reason, you should use this command, or this option. In fact, I'm going to force it to do the non-intuitive thing. Actually, I thought I thought it was vars and not var. Okay, I guess it works either way. What I've done here is I've actually forced matlabFunction to choose the order in which x2 is the first argument and x1 is the second argument. The point here is that using this argument allows us to control the order of the variables. And so that allows you as the programmer to specify what is intuitive. Now this example is not intuitive. I would not put x2 as the first variable. That could cause all kinds of confusion downstream, but I wanted to demonstrate that you can control it. So also let's actually explore the subs command. So I'm going to copy this command. So I'm back in my function derivative 1D, and I'm going to avoid using matlabFunction. So I can accomplish my goal here differently. So I'm going to say at xn, x meaning x numeric, and I'm going to say subs f prime symbolic, and I'm going to say x and xn. Okay, so what this will do is then define a MATLAB function in which your variable is xn. It's a MATLAB variable, and it plugs in the xn value into the symbolic expression, and this should work. So let's. I'm just going to clear, and let's just define a function. I'm going to say. I'm just going to say f1 equals at x to the power 4. Okay, and I'm going to say function derivative 1D F1. It would appear that, okay, says I mistyped it. I don't know what I mistyped though. Oh, capital F, of course. Okay, so now what seems, what seems different here is actually didn't do the work. It actually, hold on, F prime symbolic. That seems wrong. I wonder if no, I did type it right. So, well, this seems to be a problem. Okay, I think it's just not doing the operation in the right order. So I don't think this is going to work. Let me show you the problem. So now if I say F1 prime equals F function derivative 1D F1. So if I say F1 prime of, say, 2, I think it's, oh, that actually worked. So it should be 4 times x cubed. So I'm actually surprised that worked because f prime symbolic should be a local variable for the function derivative 1D. So let me, what I would have done to fix it is actually do this. So I would have actually done the symbolic derivative in the expression. I guess I don't even really need this line now. So let's actually run that. Okay, so yeah, okay, I'm learning something here. So it actually seems to defer the calculation of the actual derivative, but what surprises me is that that actually seems to work. So if I say f1 prime of 2, it actually does the math. So okay, this works. Now one thing that can happen is let's actually send it 1/2. Notice that it actually outputs a, actually, is that the right answer? So f1 prime, actually that is the right answer. So, but notice that it didn't output 0.5. It actually outputted a fraction. And this is one quirk of symbolic operations. So fractions are actually the sort of mathematically correct way to handle a lot of analytical math because fractions can be more accurate than decimals. Like for example, 1/3 is not exactly the same as 0.33. They're close, but they're not exactly the same. You have to actually carry an infinite number of digits, 0.3 repeating, to actually get 1/3, right? So symbolic, software usually tries to stick to fractions if you give it fractions. Now, in numerical methods, we usually don't want that. So we want to actually force, the program to actually output a decimal number. So double is short for double precision floating point. And so if we now rerun function derivative 1D with that double, and we run, you enter 1/2, it actually forces that into 0.5. Now here's, let me show you a problem that occurs with this way of doing things. So this is actually perfectly fine for calculating the first derivative. But if we calculate the second derivative, so if I say f double prime is the function derivative 1D of f prime. Let's see what that does. So f double prime, it gives me an error. The problem is that what this would have to do is convert an expression twice into symbolic math, so in order to do the derivative twice, and that actually causes problems. It actually, notice if you actually look at this line, I don't think it's even correctly defining the second derivative. It's because this double command, I think, interferes with this function's ability to convert between a MATLAB function and a symbolic function. So this kind of problem will actually not occur if you use the MATLAB function. So let's come back to this, and I'm going to just input the f prime is the derivative of f of x with respect to x. So now I'm avoiding the double and subs notation. So let's now see. I have to remember. Did I call it f1? Okay. So now if I say function f1 prime equals what's wrong with me? F1. I'm going to use a capital P this time. Is going to be function derivative 1D of f1. Sorry. Okay, so now I'm going to say f double prime is now the function derivative 1D of f1 prime. And it actually has no problem doing a second derivative. So the advantage of the MATLAB function implementation is that it does a better job of switching between symbolic math and MATLAB functions. So that concludes this video. My purpose was to show you how to make a function like this and also illustrate the difference between symbolic math and MATLAB variables and functions.